Okay, now let's look at perpendicular bisectors. So we've already looked at finding the midpoint of two points, and yeah, and also we've looked at what perpendicular lines are. So a perpendicular bisector is a line which is perpendicular and cuts a line segment into two equal parts. So if we have the points A and B, the perpendicular bisector of AB would cut AB in such a way that AM equals to MB. So a perpendicular bisector involves a combination of finding the midpoint and then finding the gradient of the perpendicular line and so on. So yeah. So first I will explain how to actually find the equation of a perpendicular line, and then we'll actually move on to working out the examples. Okay, so first let's read the statement again. The perpendicular bisector of AB is a line which is perpendicular to AB and passes through its midpoint M. So what you're supposed to do first of all is find the midpoint by finding x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So when you find the midpoint, we have one coordinate. So when we have the coordinate, we can find the gradient. We can find a gradient by doing the negative reciprocal of it. So now we have the gradient, we also have one coordinate, and then we can just use the normal formula that we use, which is y minus y1 equals to m into x minus x1. So when we do that, we will find the equation of the perpendicular bisector of AB. Okay, so now let's work out this example. As I told you, we're supposed to find the midpoint. So now let's find the midpoint. So m would be 3 plus 1 divided by 2, comma, negative 3, negative 1 divided by 2, which is 4 divided by 2, which is 2, and negative 2. So that's the midpoint. And now we'll find the gradient. So that would be negative 1, negative of negative 3 divided by 1 minus 3. So that's going to be negative 1 plus 3, which is 2, 1 minus 3, which is negative 2. So negative 1. So we have the gradient, we have the midpoint. This is the gradient of the line. So the negative reciprocal of this would be 1. So m equals to 1. Okay, now that we have this, let's find, we have the midpoint and we have the gradient. Okay, now let's find the equation. So it would be, let's use a different color. So it would be y plus 2, because it's negative, 1 into x minus 2. So it would be y equals to x minus 2 minus 2. So that would be x minus 4. So this is our equation. Let's cross verify. Yes, this is what we also got. Now let's solve the next one. Okay, so now let's find the midpoint. So the midpoint of this would be the following. So 1 minus 3 divided by 2, comma 3 plus 5 divided by 2. So implies that m is, that will be negative 2. So this is going to be negative 1. And 8 divided by 2 is 4. So our midpoint is this. Now let's work out the gradient. So finding the gradient. So that's change in y by change in x, which is 5 minus 3 divided by negative 3 minus 1. This is going to be 2 divided by negative 4, which is negative 1 by 2. Therefore, gradient of perpendicular bisector, I'm just going to write PB, is the negative reciprocal, which is going to be plus 2. So we have this and we have this. So now let's find the equation. So it's going to be finding the equation. So it's going to be y minus y1 equals to m into x minus x1. So y minus 4 equals to 2 to x plus 1. Let's expand this. So this would be y equals to 2x plus 2 plus 4. 2 plus 4. So it's going to be 2 plus 6. So this is our answer. So always try to write it in such a manner. Over here I was supposed to write finding the midpoint. So it will be easy for you to yourself and for the examiner. Let's look at the answer, which is also the same. Okay, so if you've understood perpendicular bisectors, then I will move on to the next topic. But just remember that perpendicular bisectors is extremely important in the exam, because I'm pretty sure it comes in every alternate paper. So it's pretty important. Now let's look at transforming relationships to a straight line form. So sometimes the variables x and y may not be related linearly. Some examples include y and x to the power of 3, or square root of x. So variables like that are not related linearly. So in that case, you're supposed to manipulate a few things in order to get it linearly. So even if x and y are not linearly related, it is sometimes possible to use a straight line graph to display the relationship. We can do this by changing the variables on the axis. So now let's consider the following equation, which is y equals to 2 into x to the power of 2 plus 1. You know that the graph of this will be this, right? It's an upward opening parabola, and as you can clearly see, it's not linear. But then we can change the value the variable on the x-axis in order to make it a straight line. So if we wrote x squared here, and this would be y, this would be a straight line. You can see this is in the form of y equals to mx plus c, where m, or the gradient, is 2 and y-intercept is 1. You can clearly see that 0, 1. So y-intercept 1 and the gradient is 2. So you can transform them. And now let's look at the worked example. So we're supposed to find y in terms of x. So first you can find the gradient here, which would be 2, and then the y-intercept is 5. Now you can write this in the form of y equals to mx plus c, but then instead of writing x, you can write x cubed, because that's the variable on the x-axis. So if you do that, you get y equals to 2x cubed plus 5. We'll look at the next example. They have done the same thing. They found the gradient first, which is 3 by 4. And then we don't have the y-intercept, so we'll just use one of the points, and we find in the gradient intercept form by doing y minus y1 equals to m into x minus x1. So when you simplify it, you get this. Instead of writing x, you have to write the square root of x. So that's pretty simple. Now we look at how to transform this equation. We look at how to transform this into a linear relationship. So first, you can apply logs to both sides. So let's do log of y equals to log of a into 10 to the power of bx. This would be log a plus log this. So we can simplify this to bx plus lga. If you see, this is in the form of y equals to mx plus c, where y is lgy, x remains x, and the gradient would be b, and the constant would be lga. So yeah, this is how you transform this into a linear one. Let's solve another question. So write y in terms of x, giving your answer in the form y equals to a into 10 to the power of bx. All right, so first let's find the gradient. So the gradient would be the change in y by change in x. So first it would be 4 minus 3 divided by 6 minus 3, which is 1 by 3. So that will be our the value of m. And now let's use this coordinate, which is 3 comma 3, in order to find our equation. Okay, so y, this will be not y, it will be lgy, because on the axis it's lgy and x. So lgy minus 3 equals to 1 by 3 into x minus 3. Okay, so now let's simplify this. lgy equals to 1 by 3x minus 1 plus 3. So this will be 1 by 3x plus 2. And now let's write this in terms of y. So y will be 10 to the power of 1 divided by 3x plus 2. But then they want the answer in the form of a into 10 to the power of bx. So now let's rewrite this. So this will be 10 to the power of 2 into 10 to the power of 1 divided by 3x. 10 squared is 100 into 10 to the power of 1 divided by 3x, where a equals to 100 and b is 1 divided by 3. So this is our final answer. So we're done with this chapter, the straight line equation chapter is done. I hope that all the topics that we've covered in all the videos covering the straight line graphs is clear, and make sure that you practice a lot of questions. And yeah, keep solving past papers to improve your score, and don't forget to subscribe to my channel and give this a like.